Hey guys, I hope you are doing well. Today I'm gonna teach you practical wear design using online tools from V-Notch to WES standards. Okay, let's start from V-Notch wear fully contract. Okay, click on this section, and as you can see, for this wear type, the formula which is used for estimation of flow is like this. And also, in order to find more information about this wear type, click on description, and in this section all related information for this wear is presented. And for V-Notch, for the fully contracted case, this website or these tools uses the Kinzo-Water and Shen formula presented as this, and it depends on CE, theta, H, and K. And also for CE and K, you can use this formula, which these formulas are function of theta. And also for using this, where we have some limitations, such as the head or edge must be lower than 38 centimeter, width must be larger than this parameter, and also the ratio of B per H and H per B must be higher than 2 and lower than 0.2 respectively. Okay, let's select the unit and enter the head value, for example 1.5 meter, and the width parameter. In this figure you can find out that this value equals the channel width, especially for rectangle type, and also width B for both contraction sides. For example, I want to select 3 meter. However, keep in your mind that the ratio of B per H must be lower than 2. And also the angle, let's assume that the angle of this section is equals to 45 degree. Okay, calculate the parameter, and as you can see, the discharge value equals 1.56 cubic meter per second, and also the ratio of H per B is lower than this value. Okay, let's come back to the first page and close these windows. And also the V-Notch wear partially contracted case, the formula for calculation of discharge is relatively different from the fully contracted. And also click the SI metric, select this value for H, for B, for the P, I mean the elevation of or height of the weir. And as you can see, the discharge value is calculated as this value. And also, if you click on the description, you can find more information about the partially contracted weir, and the formula which is used for calculation of flow value is presented here, and it depends on CE and the H value. And this tool uses the ratio of H per B and P per B to calculate the CE coefficient or discharge coefficient. For example, if the ratio of H per B equals 1.2 and the P per B equals 0.3, by the intersecting these values or these curves and go to the left side, you can find that the CE value range from 59 to 60. And also these are the limitation of these Weir. Okay, so let me close. Okay, one of the most important and most widely used weirs in irrigation channel is the Cipolletti weir. And Cipolletti weir is one of the simple and practical methods, and just it depends on L and HL is the length of the weir and H is the head of the weir. And so let's select the metric, the headwater, the length of the weir in this figure. P is the elevation or the height of the weir, for example, equals 3, and the width B for the contraction side of both sides of the weir, for example 2 meter or 3 meter, and then press calculate, and it means that this information leads to discharge value based on Cipolletti weir. And also for more information about this weir and other weir types, you can refer to the USBR manual for more information. And also the rectangle weir is one of the other most widely used weir type, and it depends on coefficient of discharge coefficient, length of the weir, KB parameter, and head of the weir. Okay, let's click on description, and you can find more information about this practical weir, and you can see that the correction factor, I mean KB, depends on the ratio of L per B. In other words, you should divide L per B, and based on this curve, you can go to the left side and find the appropriate KB parameter. And also for the estimation of discharge coefficient, I mean CE, you need to have the ratio of HP and LB. For example, let's assume that H per B equals 1.6 and the L per B equals 0.8. By intersecting this value and this curve and go to the left side, you can find out that the discharge coefficient for this case ranges from 3.4 to 3.6, and also this weir have the limitation like this, and just as I think this information is enough. And also head H, for example 1.5, L equals 10, width B 20, and the height of the weir equals 3, and press calculate, and it leads to about 33 cubic meter per second for this case. Okay, in order to keep this video in a reasonable range based on the duration, I want to stop here, and I will continue in the next section. I have a good time. Bye bye.